right, so today we are going to talk about slope-intercept form, which should be something that you've seen before at least, so hopefully it looks familiar as we start going through it. If you don't already, you need to have your book out and turn to page 175 here, because that's where we're starting out at. All right, sorry, it's hard to get it exactly where I want it there. So when a diver descends into a lake or ocean, pressure is produced by the weight of the water on the diver. As a diver swims deeper into the water, the pressure on the diver's body increases at a rate of about 1 atmosphere of pressure per 10 meters of depth. The table and graph below represent the total pressure, Y, on a diver given the depth x underwater in meters. So we've got water as our independent variable, the depth under the water, and then pressure as our dependent variable here, so we can see both the chart and the graph there. So number one, this is what we had done in some of the last couple lessons, asks us to write an equation that describes the relationship between the pressure exerted on the diver and the depth. So, if we look at this, remember that when we are writing a linear equation, we need to find the slope first. So it's probably easiest to do that from the table here. Remember that the slope is our constant rate of change, which is our delta y over delta x. So if I look at my change in y here, 1.1 minus 1 is 0.1. 1.2 minus 1.1, also 0.1. And if you look at all the others, it's the same thing as we go all the way down. So now we just have to check the delta x's. 1 minus 0 is 1. 2 minus 1 is 1, and these are going up by 1s every time as well, which means that our delta y over delta x is going to be 0.1, that was the change in the y's, over 1, which is 0.1. Now remember, we're allowed to use a decimal here because it's a real life situation and because they gave us decimals in the original problem. So I know from what we've studied in activity 11 that anytime I write a linear equation that the slope becomes the coefficient of my x. So I know for sure that I'm going to be writing something that's y equals 0.1x, and then I know I'm either going to have a plus or a minus something right here. So remember that what we had done previously was we had plugged in an x and a y value that would allow us to solve for this. So we can do the same thing here. The one we used back in activity 11 was when x was 1, so we can follow that same pattern here, although it doesn't really matter. We could pick any of the points we wanted. So if I plug in the y value of 1.1 and I plug in the x value of 1, that will allow me to figure out what my question mark is. So 0.1 times 1 is of course 0.1. So I've got 1.1 equals 0.1 plus something. And so this is pretty easy to figure out what our something is. I need to add 1. So 1 is going to be what I write here. So my final answer is going to be y equals 0.1x plus 1. And remember that we can confirm that by plugging in any of these x's. We should get the y that corresponds. If I plug in x equals 5, 0.1 times 5 is 0.5, plus 1 is indeed 1.5. So I see that it's working there. Now remember, we could have, of course, also tried to count slope from the graph, but since the change is so small, it's easier to do from the table here. So we wrote the equation, and in the process, we already answered number 2. So we know that the slope of the line is 0.1, or if we wanted to write it as a fraction, because normally we write them as a fraction, that would be 1/10, because that's how we read this number, is 1/10. What are the units of the slope? So it's asking me to put it kind of in real life terms. So remember that this is often written per. So in this case, we're getting 1/10 of our pressure measure per meter. And if we look back up, it was atmosphere of pressure was the unit. So that means that our slope unit is 0.1 atmospheres of pressure per meter. And so that would be the units. Number 3, what is the y-intercept? Remember that the y-intercept is the place where it crosses the y-axis. So if I look here, it hits the y-axis right there, which we're counting by ones on that axis. So we would say the y-intercept is at 0, 1. Remember, from earlier in the unit, we always list intercepts as ordered pairs, so do not just write 1. We need to say 0, 1 as the ordered pair. Explain its meaning in context. So again, that's just putting the real life labels on it. So we would say there is 1 atmosphere of pressure when the diver is at 0 meters under the surface or under the water. So basically, when the diver's just right on top of the water, before they even go under to dive, there's 1 atmosphere of pressure there. All right, so here is something that is super important, so you need to highlight it, star it, underline it, circle it, whatever it is you do, because this is something, if you have forgotten it from 8th grade, that you need to remember now. And that is slope-intercept form for a linear equation. We're going to learn lots of forms of linear equations, but this is the slope-intercept form. And that is y equals mx plus b. Hopefully that sounds familiar. It's also important that you know that m stands for slope and b represents your y-intercept. So 0b is the y-intercept. So if we look at number 4, it's asking us to identify the slope and the y-intercept of the line described by this equation, y equals negative 2x plus 9. So slope is the m, that should be the coefficient on the x, so in this case that's negative 2. So I can just write m equals negative 2, that means slope. And then the y-intercept, I don't just write b equals, I need to list it because it's an intercept. The b value is 9, and so when I list my y-intercept, I list 0, 9 for that. All right, turn over to the next page, and now it wants us to create a table of values for the line we just looked at. Remember that when we're creating a table of values, all we're doing is plugging in the x's and finding out the y's. So I'm going to show my work over here. Maybe I'll do it over here in the my notes part, but I'm doing y equals negative 2 times x plus 9. So in this case, negative 2 times 2 is negative 4 plus 9 gives me 5. Then I go on to plug in when x equals 0, y equals negative 2 times 0 plus 9. So 0 plus 9 is 9. And then continue on down the line. So negative 2, oops, I messed this up. Hopefully some of you caught that, that I thought that this was 2. I didn't even see the negative when I plugged it in. So that's important, actually, because negative 2 times negative 2 is not the same as positive 2. Luckily, this one was 2, otherwise I might not have caught it. But negative 2 times negative 2 is positive 4, which then gives me 13. Sorry about that. So now we go to the one that is actually 2, and we already know the answer, which is 5. Then go to 4, so negative 2 times 4 plus 9. This is negative 8 plus 9 gives me 1. Then for 5, I get negative 10 when I multiply, plus 9 gives me negative 1. So go ahead and plot the points over here on the graph. I'm going to plot mine as well, but obviously you'll need to look at your book a little closer to do that. So go ahead and plot those points. So hopefully as you plotted those points, you see that they are indeed forming a line. Not all the points are equally spaced, but they do all fall on the same line. It's very hard for me using this tool to connect the dots because it's going up and down and it's not flat on my paper. So I'll try my best here to connect. A little messy. Hopefully yours looks better than that. Now, number 6 asks you to explain how to find the value of slope from the table. So this is review. We already know what the slope is. Here we're trying to make connections between what we already should know and what we're talking about now with y equals mx plus b. Remember that when we want to find the value of slope from a table, we need to find delta y and divide it by delta x. So in this case, if I use a different color here, let me grab green maybe, and I look at here my delta y and delta x just from my first pair, 9 minus 13 gives me negative 4. 0 minus negative 2 gives me positive 2. So the value of the slope of the line is negative 4 divided by 2, which is negative 2. So negative 2 is the slope of our line. Again, remember that you can find delta y and delta x by any two pairs. So it didn't have to be these first two. If we had gone down here instead, negative 1 minus 1 is negative 2, 5 minus 4 is 1, negative 2 over 1, still negative 2. So it shouldn't matter which one we choose. Number 7 wants us to explain how to find the y-intercept from the table. So we should already know what the y-intercept is, but this is, again, making connections, just pointing out how, when you haven't already seen the equation, you could find the y-intercept. Remember that because the y-intercept is on the y-axis, that the x value is always 0. So we just need to find the row in the table where x is 0, that is the y-intercept. So if I look at my table here, I can indeed see that I've got 0, 9 right there, which we already knew was my y-intercept, and now we're confirming that we can find that from the table, not just from the equation like we did on the previous page. Next, explain how to find the value of slope from the graph. So again, this is review. We've already found slope from a graph. It was on your last quiz. Same with y-intercept. But this is just reviewing very important skills. So remember that to find the slope from a graph, we need to count the units of rise and run between any two exact points. Slope equals rise over run. So if I go up to the graph here and I pick any two exact points, so let's say I pick these two right here. If I draw my little triangle that I've taught you guys to do here, If I draw my triangle, if I'm going from this point down to this one, I went to the right 2 units, right values or positive values. Then I went down 1, 2, 3, 4. Remember, down values along with left values are negative. So my rise is -4, and my run is 2, which gives me -2. Again, notice that's the same thing as what we got in 6. Number 9, explain how to find the y-intercept from the graph. That, again, is just by definition. Find the point where the graph hits the y-axis. So if we look up again, here's my y-axis, there's where it hits. It is, as we already know, at 0, 9. Again, notice, same as what we found from the table, same as what we found from the equation looking at y equals mx plus b. So just showing you again and reviewing these important skills that I hope we're not going to lose. All right. Number 10, 11, 12, 13, the check your understandings here. First thing I want you to do is go ahead and try these. You can work in your groups if needed, but take the next, I don't know, 5 minutes or so. So go ahead and hit pause on the recording while you work. So take some time here to go through and work through these check your understandings. All right, looking a little more at how much we have left, I would say maybe let's take 10 to 15 minutes here. No more than that. You should definitely be able to come up with some good answers. Discuss in your groups to these 4. When it's talking about write the equation of the line graphed in my notes, it's talking about this one. So that's the one you're looking at here as you're trying to do these. So again, just hit pause on this and then come back once 10 to 15 minutes is up and you've got your answers. All right, so let's check the work that you did here. Number 10, what are the slope and the y-intercept of the line described by y equals -4/5 x minus 10? So remember that our slope-intercept form of the equation of a line is y equals mx plus b, where m is slope and b represents the y-coordinate of the y-intercept. So m is the coefficient of the x, so that means that you should have said that the slope, or m, is -4/5. The y-intercept, my b value here is -10, which means that 0, -10, should be your y-intercept. So if you didn't get those correct, hopefully that makes sense, and go ahead and correct your answers, because those are what we want to have there. Number 11 wants you to write the equation in slope-intercept form of the line represented by this table. So again, this is what we just went through on the previous page, showing how to calculate the slope and the y-intercept from a table. So we need the slope first, which remember is delta y over delta x. So I can choose any 2 points. I'm just going to choose the first set just for convenience. So delta y, 7 minus 9, is -2. And then -1 minus -2 here, which is really -1 plus 2, gives me 1. So that means in this case my slope is -2. Sorry, my pen did something crazy there. Doesn't really look like an equal sign, but m is -2. Remember that from a table, When I'm looking for the y-intercept, this is what we said on the previous page, so you can come back here to see the words that describe how to find it. From a table, the y-intercept is the row where x is 0, so in this case it's a column because the table's going the other way. But there's my y-intercept, which means the b value is going to be 5. So you should have written y equals negative 2x plus 5. All right, number 12, write the equation in slope-intercept form of the line with a slope of 4 and a y-intercept of 5. So again, this is telling you m equals 4, b is the y-coordinate of the y-intercept. So that one should be pretty fast. Y equals 4x plus 5. All right, last one, 13. Write the equation of the line graphed in the My Notes section. So again, if you already forgot what we did in 8 and 9, go back and look. See how we found the slope from a graph and the y-intercept from a graph. That's why we wrote it out in words here. So in order to find the slope, I need to count rise and run between two exact points. So I see an exact point here. I see another one here. So I'm going to count the rise and run from the triangle that I've just drawn. So my run, 2 units, my rise, 1, 2, 3, 4, and I went down, so it's negative. So that means my slope again is negative 2. That seems to be their favorite slope today. The y-intercept is the place where the line crosses the y-axis. So that's right here at 0, 6, excuse me. So that means my b value is going to be 6, which means the equation of my line is y equals negative 2x plus 6. All right, so now we've done some practice of how we can write the equation of our line, how we can use the equation of our line. Now we're going to look at a real life situation here. Monica gets on an elevator in a skyscraper. The elevator starts to move at a rate of negative 20 feet per second. After 6 seconds on the elevator, Monica is 350 feet from the ground floor of the building. Number 14 says the rate of the elevator is negative. What does this mean in the situation? What value in the slope-intercept form of an equation does this represent? So, the rate of the elevator being negative, when we're thinking about what that means in real life, that means the elevator is moving down. So that's the answer to the first part. What value in the slope-intercept form of an equation does this rate represent? So remember that rate of change, that's the slope. So it represents the slope. 15A, how many feet was Monica above the ground when she got on the elevator? Show how you determined your answer. So we know that the elevator is moving at a rate of negative 20 feet per second, and that after 6 seconds, she's 350 feet from the ground floor. So that means that we know that she had been going down for 6 seconds, which means that originally when she got on the elevator, she was higher up. So that means that we're going to be adding to the 350 feet a positive value. So the slope is negative, but we're going the opposite direction of the slope. So we're going to make it positive, so 20, because we're going up to work backward. And then she went up, or well, she went down, but we'd be doing 20 feet per second for 6 seconds. So 20 times 6 is 120. So we have 350 plus 120, which gives you 470 feet. So that means She was 470 feet above the ground when she got on the elevator. Then she got on the elevator, it started moving at a negative rate, so 6 seconds later she's only 350 feet from the ground floor. So she's starting to come down toward the ground. 15b, what value in slope-intercept form does your answer to part A represent? So this is where she started when time was 0. So remember, when time is 0, time is my x value essentially in this case. So that means that this value 470 represents the y-intercept. So it represents the y-intercept there, or the b value. So 16, write an equation in slope-intercept form for the motion of the elevator since it started to move. What do x and y represent? So we already know the value of m because that was our rate, and we know the value of b because we just found it in 15a. So when we write the equation in slope-intercept form, then we would write y equals negative 20, because that was the rate, x, and then plus, where she started above ground was 470 feet. So what do x and y represent? X represents time in seconds. And y represents height in feet. What does the y-intercept represent? So the real life meaning. So we would just say that that's Monica's starting height. Part B, use the equation you wrote to determine at this rate how long it will take after Monica enters the elevator for her to exit the elevator on the ground floor. Explain how you found your answer. So if we're at the ground floor, that means that we know that the height is 0. And we know that height is represented by y. So what we can do to figure out how long, which is x, is plug in, so we'll explain first, plug in 0 for y because height is 0 on the ground, and solve for x, which again is representing time. So if I plug 0 in for y, I've got 0 equals negative 20x plus 470. So I would, in order to solve for x, subtract 470 first. So that would give me negative 470 equals negative 20x. Then my next step would be to divide by negative 20. And that doesn't come out evenly, but this is a real life situation, so we're allowed to use a decimal. We get x equals 23.5. And it asked how long. We do need a label here, so it'll be 23.5 seconds that it would take her on that elevator trip. All right. Next thing that I want to do is number 17, because this will become really important later in this chapter. So if we can start practicing it now, that's going to be a really, really good thing. Also, we're going to need this idea for when you do number 19 in your homework, because it's important that we can start with something that's not in slope-intercept form and then be able to identify the M and the B. So when I start in this form right here, I need to, and I'm going to write the steps out here, I need to get y alone oops, 17, not 1, by using inverse operations or opposite operations. So that means first I'm going to subtract the 3x. So those will cancel out. Now, over on this side, this is the same thing we did in Unit 1 when we had formulas, and some of you got confused because there were so many letters. 16 is not a like term with something that has x's. So I cannot actually combine these. They just now go on the same side. So on the left side, all I have remaining is negative 2y. On the right side, these were not the same. They're not like terms, so I just put negative 3x because, again, we're trying to get it in slope-intercept form, so I know x's come first. And then the 16 was positive, so I put plus 16 because this, if it had no sign, that means it was a plus. Now, y is still not alone. I next need to divide by negative 2, which will cancel these out. Now, when I do that, the next thing I need to do is simplify the x side by separating the slope term from the y-intercept. So that means when I divide these, I'm going to separate them. So I'm going to use a different color here to illustrate this. Because when I divided by negative 2, it means I need to divide everything by negative 2. But I want it to be mx plus b. So my m is going to be negative 3 divided by negative 2. So negative 3 divided by negative 2, two negatives divided make a positive. And 3 over 2 doesn't reduce. So that's just going to be 3/2 x. Then, if I use green here, the b term is going to be this guy, 16 divided by negative 2. That does come out evenly. That gives me a minus 8. So my slope-intercept form of this equation here is going to be y equals 3/2 x minus 8. Again, this is what you're going to need in number 19, because once you have it like this, then you can say, oh, slope is 3/2, y-intercept is 0, negative 8. All right, that wraps up this lesson.